Okay, so this is about question number 5, and so I'm going to give you some example to construct the matrix for a given spring system, so that based on that understanding you'll be able to solve how to the problem number 5. Okay, so this is a spring system, so some of the springs which are in series, okay, and where this end and the other end are fixed. Okay, so it's a fixed spring system. Okay, so here if we see, we have 3 nodes, 1 2 3. Okay, and at each node a force is being applied. This is node 1, and at node 1 the force which is being applied is F1. Okay, and here it's F2 and here it's F3, and similarly the displacement of this node is U1, and here it's U2 and here it's U3. Okay, so what do we mean by matrix, that matrix which we are talking about? Okay, so now let me write a force vector, okay, as a column vector. So it's going to be F1, F2 and F3. Okay, and the displacement vector, give me a sec, and the displacement vector which is U1, U2 and U3. Okay, and these things can be equated using a matrix, and that matrix is what you need to construct. Okay, so now how to construct this matrix? So in order to construct this matrix, what you have to do is you need to use equilibrium equation. Okay, so equilibrium equation we have to apply for node 1, node 2 as well as on node 3. So let me just give an example by applying it on node 1. Okay, so say this is node 1. Okay, so I have just drawn a free body diagram. I'm going to draw a free body diagram on node 1. Okay, so on node 1, what are the forces are being applied? So one is F1 is being applied. Okay, so that's F1. Okay, and then what are the other forces? One force will be from this spring 1. Okay, so the spring 1 will exert a force on node 1, and it will be on which direction? So if U1 is in this direction, okay, if U1 is in this direction, then the spring force will be in the direction opposite to U1, so which means it will be in this direction. Okay, and what will be the force? Let's say the stiffness of the spring is K. Okay, and in that case K into U1 is the force which is being applied due to spring 1. And now what about the force exerted due to spring 2? Okay, so that will be, let's say for our assumption, U2 is greater than U1. Okay, it doesn't matter even if you assume in an opposite sense. Okay, now just for the illustration I'm going to use U2 is greater than U1. If that's the case, okay, what will be the force due to the second spring on node 1? And that will be so if U2 is greater than U1, then the spring will be in tension. So I guess it will be in this direction, and the force is U2 minus U1. Okay, so these are all the forces which are being applied. Now for this, let's construct let's use an equilibrium equation. So K, let me take K as common. Okay, so now okay, Okay, so minus k, I'm going to take minus k to u1 minus u2, okay, which is equal to f1. Okay, so that's the equation when I apply the equilibrium equation at node 1. And if I know that, then I could fill the first row in this matrix. Okay, let me take minus k as common, and then what will I have here? I will have 2, minus 1 and 0. Okay, similarly, if I apply the equilibrium equation at node 2, I will have minus 1, 2, minus 1, and similarly here 0, minus 1, 2. Okay, you can check. And what is this matrix? This is nothing but K3. Okay, so that's how we can construct a matrix for a given a spring system, spring connected system. Okay, and if we have a system like free and then free fixed, then we will have T3. So this 3 represents number of rows or number of columns. That depends on the number of nodal points. Okay, and if we have spring, say here one node, spring, here one node, then we will have B matrix, B3. Okay, and here if in case if we have and then a spring which is being connected like this, then we will have C3. Okay, so that's how we need to construct this matrix. And for our case in the assignment, it's like, okay, and one more spring. Okay, no, I think here we have, so 1, 2, 3, 4, 5. Okay, I think there's one more spring, and here fix, and then these two things are being connected and these two things are being connected. Okay, so here we have 4 nodes. So the matrix which you are going to have is a 4 by 4 matrix. Okay, but what are all the entries? Okay, so that's what you need to identify. Okay, so that's about the question number 5 in the assignment 1. Thank you.